Hi, my name is Johnny Hancock for Keysight Technologies. I'd like to give you a short demonstration of how to set up a Keysight InfiniiVision X-Series oscilloscope to trigger and decode on CAN FD, or flexible data rate signals. But first, let's take a look at a diagram to understand the difference between standard CAN 2.0 and the new protocol CAN FD. CAN FD, which stands for Controller Area Network with Flexible Data, is a fairly new protocol that grew out of CAN 2.0 and is used primarily in automotive applications. With CAN FD, baud rates can increase during the data phase of each frame, and maximum number of data bytes can be extended from 8 bytes up to 64 bytes when compared to classic CAN 2.0. As shown in this timing diagram, faster data rates and more data per frame can significantly reduce bus load and increase overall throughput, which is really needed in many of today's more demanding automotive applications. Let's now see what CAN FD waveforms look like on an oscilloscope. First, I'll select Auto Scale to automatically scale the vertical and horizontal. Then I'll bring up the Serial Decode menu and select the CAN protocol, which also supports CAN FD. Next, we'll go into the Signals menu. This is where we can define the settings for both the standard rate and FD rate. For the standard rate, this is 500 kilobits per second, and we can use the default setting of 80% for the sample point. And for the FD rate, we have 10 megabits per second, and again, we can use the default setting of 50%. Now, if you're just working with classic CAN 2.0, you don't have to set up anything in the FD menu. Now, I'm going to change the time base 20 microseconds per division to get a couple frames on screen, and also turn on the protocol lister so we can see the protocol decode in 2 formats. So now we're decoding, but we're not yet triggering on CAN FD. So let's set up CAN FD now. First, I'll pull up the trigger menu and change from triggering on edges to trigger on CAN. And it defaults to trigger on the start of any frame. Now this looks like a pretty stable trigger, but I've only got 2 repeating CAN FD frames here. Typically, you're going to want to trigger on something more specific. This is the CAN and CAN FD trigger menu. The most typical trigger is trigger on a data frame ID. And let's enter an ID. I'm going to enter 530 hex. And now we have a very specific trigger condition. Now what we can see now here is you can very clearly see the standard data rate, 500 kilobits per second, and then you can see here during the data phase it increases to 10 megabits per second. Now we can zoom in on this a little bit and see these bits a little closer. And so this particular bit right here is the BRS, or bit rate switch bit, and then you see following that is the beginning of the DLC field and then the data field are all at the FD rate. Let's now take a look at CAN and CAN FD error analysis. I'm now probing a signal, a CAN FD signal, that has errors in it. In this screenshot right here, you can see that we have stuff bit errors and error frames. And the scope clearly identifies several different specific type of errors. We can also trigger on specific type of errors. Here you can see error frame, acknowledge error, form error, stuff error, CRC error, spec error, which is all of these individual errors except error frame, and then any kind of error at all. So let's trigger on stuff error, and there we lock right in specifically on the stuff error. If I want to, again, I could zoom in on that stuff error, see it a little more clearly. This bit right here is 6 bits wide, which is not permitted in CAN FD, and then it's followed by an error frame. Let's change the time base, as you would expect. Now, in addition to triggering on specific type of errors, you can also filter by frame ID. So I can say only find stuff errors if they occur during frame ID 520, and then it locks in. This scope also counts errors. It has a totalizer. It's a real-time totalizer. It doesn't miss any. It displays the bus load, which in this case with these two very fast repeating frames is very high at 95%. It counts flagged error frames, spec errors, which remember is all errors except error frames, and then it counts total errors. If you would like to get more information about InfiniiVision X-Series oscilloscope, contact an authorized Keysight distributor. Thank you.